Hi there, thanks for joining us again. This is Space Nuts. It's a Q&A edition. My name is Andrew Dunkley. Great to have your company. Questions today about falling into a black hole and how can black holes get supermassive? Have they got enough time? It doesn't make sense. We'll see if we can explain that. Planets orbiting pulsars. That's a question that's been raised. And somebody wants an update on the asteroid Bennu and what's going on with neutrinos. We'll try and answer all of that on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And to furnish us with his vast amount of knowledge, he's got the brain the size of a planet he has, Professor Fred Watson, astronomer at large. Hello, Fred.
I've forgotten the name of the robot whose brain was the size of a planet.
Marvin, the paranoid android.
Marvin, that's right. Yes, it was Marvin.
Yes, Marvin.
Oh, dear, good old
and he
Marvin.
talked like this.
Yeah, he was very
have-
unhappy.
He would have been really terrible on radio.
Yeah.
No colour, no inflection. Just
No, nothing like
and
that.
yeah, everything was just the end of the world for him. Or the end of the universe, which is actually what the whole thing was about.
Yes, it was.
Yeah.
That's true. Yeah. Okay.
Let's do some questions, Fred. If you are ready and willing and able, it doesn't matter if you're able, adequacy is enough. Let's go to our first question. Long-time listener, first-time caller. I've been rereading the Three-Body Problem trilogy. Without spoilers, there's a moment where an image of someone who fell into a small man-made black hole is still visible. That got me thinking about time dilation at the event horizon. Given that extreme gravitational time dilation occurs there, how are black holes able to accrete enough matter to grow to supermassive scales within cosmological timescales? Thanks for all the time and effort you both put into the podcast. Nick from the UK, Milton Keynes, I think is the name of his locality.
It is.
So, yeah. You'd know that area, I imagine. You'd know just about every square foot of the UK, wouldn't you?
I do. I certainly know that bit quite well because my brother used to live in Newport Pagnell, which is right next door to Milton Keynes. Newport Pagnell is a charming sort of old country village. Milton Keynes is a new town, and so they're quite different, but they both had their pluses, and I'm sure they both had their minuses. He doesn't live there anymore, but that's another story, which we won't go into on Space Nuts. So what was the question?
Well, he made a reference to Three-Body Problem
Yes,
where
that's right.
someone fell into a man-made black hole and they were still visible. I must say, Nick, that I read the first book and I found it pretty heavy going, so I haven't actually tried to read the rest, but I might get around to it. They're still making the TV series, but there's a bit of a like the first season was out a couple of years ago, as it turns out now, but they initially announced that they weren't going to keep going. Then they said, yes, we are. We're going to make 2 more seasons and align them both with the 2 more books. Now they're starting to think, no, we'll make 1 more season and combine the 2 books. So we don't quite know where it's at, but great series if you haven't had a look at it, The Three-Body Problem. The first season, I'm going to watch it again because it's so very good. His question, he's thinking about time dilation at the event horizon. Given that extreme gravitational time dilation occurs there, how are black holes able to accrete enough matter to grow to supermassive scales within cosmological timelines? I love that question.
It's great, isn't it? And it's a good question too. But the crucial point here, it's all dependent on the observer's frame of rest. In other words, where you are and what you're doing. So the person splattered on the event horizon of a black hole for whom time appears to have stopped, to an outside observer, that person's already long gone. They've been sucked into the black hole. It's only their time-dilated image that we are seeing. The outside observer sees the time dilation. The person going through doesn't. They just basically experience time ticking away in the normal way, and as they get spaghettified, they probably wish they weren't there. So it's all about your kind of your vantage point, but we would call it the frame of reference. So yes, it is possible for black holes to accrete and become supermassive black holes. And you and I think, Andrew, spoke recently about the idea that black holes can become supermassive much more quickly than we thought. And I can't remember the mechanism by which that happened. We did cover it. It's a story we covered. And there was a sort of trick to it, that if you do this, then your black hole can gather material so quickly that you find yourself in the situation that we find when we observe the early universe with the James Webb Telescope. We find supermassive black holes that are much more massive than we thought they should be. We thought the accretion of material onto these black holes would be relatively gentle and a long process, taking most of the age of the universe, but it's not. It all happens within the first few 100 million years.
It's called it exceeds the Eddington limit, apparently.
Yes.
This faster growth. These objects, often reaching billions of solar masses, matured only 900 million years after the Big Bang, implying they formed extremely early and grew unexpectedly fast or had massive initial seeds, it says. Yeah. I'd have to do a lot more reading to find out that. But they refer to a feeding frenzy, abundant gas fueled a feeding frenzy. So
feeding frenzy. That was it. It's to do with the properties of the gas cloud in which it's sitting. That was right. Aha. You've reminded me. See, there's a few neurons in there that are still remembering
firing.
That. Yeah.
So it's not so unusual. It's not so unusual. Is basically what the answer is to the next question. This is. It's the time scale isn't really the issue. It's what they've got to eat.
That's right. In terms of how fast these things can accrete. But the basic premise of Nick's question is answered by the fact that you're talking about two different reference frames. We, observing the black hole from the outside, see somebody falling into it. Their time seems to go slower and slower, and it's stationary on the event horizon. But for the person themselves, they're just whizzing down through the event horizon and straight into the black hole in very long strings.
Okay, so let's just say we observe somebody who's obviously been sucked into a black hole and we can see their image there. How long would that image last? They'd have to disappear eventually, wouldn't they?
I think so. Well, probably covered up by whatever else falls into the black hole, because there's lots of stuff going in. It's something I've tried to envisage as well, and I'm not really sure of what the answer is. But I suppose if you think of it like raindrops on a dry pavement or something, where one raindrop hits and you see it, sort of sitting there, and another one covers it up, and then another one covers it up. Don't know. That's that's how the Watson brain might do it.
Yeah, that's a good example. Yeah, no, that covers it. I understand. If I understand, everyone's got it.
Hey, I should be on radio, shouldn't I?
You should. Yeah, I think you are a lot.
Oh, yes, yeah.
A lot more than I am these days, I must say. Yeah. All right. Thanks, Nick. Great question. Very thought-provoking, and thanks for sending it in. And don't make it your last time, seeing it's your first time. Our next question comes from Hazel. I have in my studies just come across something completely new to me, but sort of makes sense. We've found evidence of what look like planets orbiting pulsars. This would mean somehow these orbiting bodies survive massive stars that went supernova. Also, the sweeping beams of seriously strong electromagnetic radiation would, I assume, have some fascinating effects on these planets. As always, love the show and keep up the great work. All the best from cloudy-skied Scotland. Well, it wasn't cloudy skied when I was there because the sky was falling. It was raining cats and dogs. But I'm sure that's not uncommon. But, yes, thanks for the question, Hazel. All right, Fred, over to you.
Yes. In fact, the first planet that was discovered beyond the solar system was exactly what Hazel has just described. It's a planet around a pulsar, and it won its discoverers the Nobel Prize. This was, I think it was 1978 when that was discovered. And the first planet orbiting a normal star was discovered in 1995 by Mayor and Queloz were the two scientists who discovered that. But the one orbiting a pulsar it's partly because pulsars are very, very accurate clocks, and you can use the accuracy of their clocks to time basically how they're rotating and whether there's anything gravitational going on in their environment, and that's how the planet was discovered. The first planet known to exist beyond the solar system. Quite a big discovery. So there are others like that now, and others known to be in the same situation. And I think the question Hazel postulates is still an active question. How does a planet survive that kind of scenario? Did it form after the supernova explosion, form in the debris of what happened, or did it survive the supernova explosion? And I'm not sure what the current thinking of my learned colleagues is on that, but I might ask them because I think it's a valid question. For a long time, it was a puzzle. How does a star that goes supernova, how does it still have a planet in its retinue?
But we're assuming that it would destroy the planet, but it might mess it up a bit, but the rocket'd still be there, wouldn't it?
Well, when you think of the energy that goes into a supernova, when it's at its peak, is brighter usually than the rest of its host galaxy. So there's huge amounts of energy there, and a lot of that's optical energy, visible light energy, but there are shock waves that we see. Shock waves will be disastrous for a planet. So my guess is it's still not well understood how a planet can survive something like that.
Yeah. What effect would those I don't know what do you call them with that come out of a pulsar?
Neutron star. The beams of radiation, you mean, caused by their magnetic fields.
So that in itself would be just horrific.
Yeah, that's right. You'd think so, because they're very powerful. That's what we see when we see a pulsar. We see the flashlight beams of energy. Yeah, not somewhere you want to be, really.
No,
so it's hard to imagine that there might be life on some of these pulsar planets.
Yeah. Do we know how many planets we've discovered that have sort of managed to survive in this environment? Wouldn't be many.
I'm sure we do. I'd have to check it out. I don't know the number offhand, but I'm sure with your adept fingering, you could very quickly tell me how many planets are in orbit around pulsars.
Yes, I'm going to do that now.
Meanwhile, I'll wax lyrical.
And the answer is the answer isn't big. As early as this year, between 6 and 8 planets have been confirmed orbiting pulsars.
That sounds about right.
That suggests the survival rate is pretty low.
Yes, it does. It does. On the other hand, stars that go supernova and create a pulsar have got very short lives. Their lifetimes are measured in tens of millions of years rather than tens of billions of years like our sun is at probably 10 billion years total lifetime. So that's, for a planet to have time to coalesce properly and form and do all the things that planets do in their infancy, it's not very long if you've got a looming explosion on your doorstep. Absolutely, yes. Thankfully, we don't live in that kind of environment. We don't. No, that's right.
Although that famous old story keeps popping up, and I saw it again the other day about the impending explosion of Betelgeuse, and we don't want to be in the way of that.
We don't know. It's about 700 light years away, so it's survivable. But
good.
We don't really want to be on the Betelgeuse side of the Earth when it goes off because of all the gamma radiation.
Exactly. But, if you read the popular press, it's going to happen next week. But it could be, tens or maybe 100,000 years or something like that, couldn't it?
It's certainly people are talking about thousands of years. That's correct.
Yeah,
yes.
yeah. Okay. Thank you, Hazel. Hopefully that sorted out your question. Thanks for sending it in, and please send us another one when it pops into your head. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Space Nuts.
Okay, Fred, we have an audio question. Let's hear from David.
G'day, David here from the Sunshine Coast, long-time listener. Fairly short question today. I see that you were looking for phone-in questions. Just wondering what we've learned with regard to the material that came back from Bennu. I haven't heard a lot in the mainstream media at all. It's been quite some time, and I know they had trouble dealing with the sample when it first came back. Just wondering if you could fill us in. Thanks very much. Keep up with the great show. See you later.
Thank you very much, and we'll see you later too, David. Bennu. It's funny that the question should turn up when it does, because I think Bennu's just got back into the news, has it not?
Yes, that's right. There's a really interesting story which came out this week in the proceedings of the National Academy of Science in the United States. And because this is a press release, it means I can read from it with impunity. And so it introduces the issue very well. Scientists studying samples from the asteroid Bennu have uncovered a surprisingly complex chemical landscape at the tiniest scales. A new study shows that at an extremely small scale, organic material and minerals inside the asteroid Bennu are organized into three clearly different chemical groupings. These patterns provide important clues about how liquid water once altered the asteroid. Bennu is a carbon-rich asteroid located relatively close to the Earth. It formed from fragments left behind after its original parent body broke apart. Because the samples returned from Bennu have not been exposed to Earth's atmosphere or weather, they offer a rare, untouched record of how water, minerals and organic compounds interacted in the early solar system. So it's a great story. It comes from scientists, I think, in the US. I'm not sure, actually. That's a good question. Where are these scientists from? We might answer that during the talk. But yes, remembering Bennu is an asteroid visited by the spacecraft OSIRIS-REx, which had a marvellous mechanism on board called TAGSAM, the touch-and-go sample acquisition mechanism, which basically sank the spacecraft onto the asteroid surface and let it grab some of the soil. Bennu is a rubble pile. It's shaped very much like two cones end to end, a typical shape for a rubble pile asteroid. So what they grabbed was quite a lot of material. I think it was, if I remember rightly, 60 grams comes into mind. That might not be the number, but it's something like that, a significant amount. So asteroid Bennu is very much in the headlines. A lot of interesting stuff. The paper that reveals these results is called Nanoscale Infrared Spectroscopy Reveals Complex Organic Mineral Assemblages in Asteroid Bennu. So that seems to be the crucial aspect of this, not the minerals and organic or carbon-containing molecules that are there, but the fact that they're organized in such a way that they have been subjected to water-related processes. And that means basically liquid water. It's quite extraordinary. Once again, reading from the press release, these uneven nanoscale structures indicate that water did not affect Bennu in a single uniform way. Instead, water interacted differently in separate areas, producing a patchwork of chemical environments across the asteroid. It's almost poetic, isn't it?
It is. It is. From my research, the sample return was 121.6 grams of material.
Okay. There you go.
4.29.
Half right.
4.29 ounces. And You're right. They the authors are from the United States, places like the Department of Geosciences, Lawrence Berkeley National Laboratory, etc. So yes, definitely a US based study that has been released on the latest from asteroid Bennu. I'm just trying to remember where that sample landed. Was that the one that landed in Australia, or was that another one?
That was
that was a Japanese mission, wasn't it?
Yeah. So Bennu's sample, OSIRIS-REx, is the spacecraft, which I think is on its way. Might be on its way to Apophis. It's been redirected. I can't remember where it's going though. What it did was dropped a capsule which has the samples in it, and they landed in Utah. That's where the landing site was. Our samples that came to Australia are from the 2 Hayabusa missions, the 2 Japanese asteroid sample return missions. Yeah,
and you're right, it's headed for Apophis.
Good, I thought it was. Yeah.
They refer to it as a mission extension to study a near-Earth asteroid, and it should arrive in April of 2029. So they're extraordinarily long missions, aren't they? When you're out there in the nether regions of the solar system.
That's right. It's that's just the way space works. You're kind of tied up with gravity and time, and you can't really do much about either of those two things.
Oh, you can in a science fiction story. It's amazing what you can do in a science fiction book.
Stories, yes.
And I keep saying it. A lot of science fiction has turned into reality over the years. So, you never know. In fact, I can't remember what the problem was, but they did actually not so long ago get science fiction writers together. I don't know if it was NASA or someone else, to try and solve a problem that they couldn't get their heads around, to see if the science fiction community could come up with an answer for them. Can't remember any more about it than that, and I wish I could, because the story fascinated me. They never called me, Fred. I obviously couldn't solve anything.
Me, Andrew.
I would have thought your prominence I would think being a best-selling author of one or two copies that have been sold over the years, that I would be the go-to guy. Not the case. Yeah. Not the case. Have we finished answering that question?
Yes, basically there's a lot going on. I urge David just to check it out on the web. There's quite a lot of stuff on Bennu. It's been interesting. I've noticed over the last few weeks things popping out, particularly about the minerals which have been water affected, which in itself tells you something about where it's come from. Somewhere where there was liquid water.
That is fascinating. Yeah. And yes, that paper was published on ScienceDaily.com. David, if you want to check it out. And the paper was published on the 31st of March. An auspicious day in history, Fred, I must say. Yeah. Yes. A certain non-successful science fiction writer was born on that day, 1962.
Was that your birthday?
Yes.
So yesterday was
yesterday our time. Yeah.
So that was your 64th, is that right?
Yes, I can officially play that Beatles song now.
Good on you. I was just about to say that.
Yeah. Yes, I can. Yeah.
Good old Paul McCartney, he hit the nail on the head.
Yeah, I watched his doco the other day. They released a doco about him. Gosh, it's amazing what I didn't know about him. That's come out now. It's quite incredible. But that's a different story, completely different story. But 64, can't believe it. Anyway, when I told my grandchildren I was 64, they looked at me and said, "And you're still alive?" No, they didn't. I said, "Well, hang on a minute. You should meet Fred." No, I didn't say that either.
I remember 64, just about.
Oh, dear. All right, let's move on. Thank you, David. Good news about Bennu, and they've just published that paper on my birthday. Our final question comes from Keith. Hello, gentlemen. Oh, well, he got that wrong straight away. This is Keith from Washington State, USA. This is my first time asking a question. We've had a couple of newbies on the show today. Looking forward to your explanation. From what I understand, neutrinos travel vast distances through space and even from our own sun. They pass through our bodies every second and easily through the Earth. But do they travel straight through a black hole, or are they captured by it? Appreciate you guys and love the podcast. Look forward to every episode. Thank you, Keith. Hope all is well in Washington State. That's on the northwest corner of the United States. Seattle's in Washington State. I love Seattle. Went there a couple of years ago now. Terrific place. Terrific. Current Super Bowl champions, Seahawks. I knew you'd be interested in that, Fred.
Keep talking, because I'm just Googling this.
I kind of figured I needed to pad, but I didn't pad long enough. Yes. See, I'm out of practice. I'm out of practice. I haven't been on radio for 2 years now, so I don't need to ad-lib like I used to. It used to be really funny when something went horribly wrong and you knew you had to fix it while you were talking. And have you ever tried to thread a tape on a reel-to-reel recorder while you're talking to an audience and making sense of what you're saying and you don't even know what you're saying? Gosh, it can be a fun moment. I miss those days so much. Are you good now?
Yes, I am. Yeah. I just you've conjured up an entirely different picture in my head of you threading a reel-to-reel recorder, which I used to remember doing.
Oh, yeah.
It's the one piece of kit that I'd like that I don't have is a reel-to-reel machine.
I can steal one for you. I know a guy in town who's got one. And if I took it, he wouldn't notice for a few years. No.
Tell me more offline.
Yes, I will. Yes. Yeah. Good morning, Richard.
Hi, Richard.
Yeah, but look, while we're talking about radio, it's changed so much because it's all digital now. So you don't really all those what do you call them, skills that you developed in radio, like cut splicing tape and drop editing and all of those special talents. They're gone. They're just gone. If you gave someone a reel-to-reel tape and said, "Here, can you just edit that piece out for me? Here's a razor blade," they'd go, "What?"
Remember to make the cut diagonally so that it doesn't impair the sound quality. Yeah.
Exactly. Yeah, that's how it works. Mm. Yeah. In fact, anyway. The splicing block had the slots in it, so you could do the diagonal cut, and it was made in a way so that the tape actually just sat in there without folding up or rolling around or slipping. It was brilliantly made piece of kit, as Fred would say, to keep the tape still. Mm.
I bet.
Look, all these memories. Gosh, I think I've padded enough now, Fred.
Yeah, I'm sure.
What was the question?
A tape splicing block. It's how do you splice neutrinos? That's the question.
Yes. Well, why do they splice? Or can they splice a black hole? That's the question.
That's the worst segue I think we've ever made, but that will do. It's as good as it gets. Adequacy is all we aim for. But neutrinos are indeed affected by gravity, as you'd expect. Because they're particles, they're subatomic particles. And so once a neutrino crosses the event horizon, then it's doomed. It will be absorbed by the black hole, just like light, basically. They hardly interact with normal matter, exactly as Keith mentions, but they do feel the force of gravity, or the warped space of gravity, and they just get pulled in the same way as any other particle. So the answer is yes, and it's it's a really interesting subatomic particle. We used to think for a while that maybe neutrinos made up the dark matter of the universe, but it turns out from other studies that they don't have enough mass to do that. So they're not the culprits, but there are a lot of them. I think Keith, I beg your pardon, mentioned the solar neutrinos. Yeah. And for a long time, there was a problem there. I think it was that we didn't see enough neutrinos coming from the sun to agree with theory, and that was called the solar neutrino problem. I think that was the way around it was. But I believe that has now been basically solved by both observational and theoretical astronomers. I should go down a rabbit hole and chase all that, because my knowledge of neutrinos is really a little bit sad. It does have the one joke that I remember about neutrinos, which is probably not worth relating.
Oh, now you've got to say it.
Well, it was when there was this idea that the Large Hadron Collider had generated a neutrino that turned up at a detector in Gran Sasso in Italy sooner than it would have done if it had not been travelling at less than the speed of light. And so it became known as the faster-than-light neutrino. In the end, it was debunked. They found it was due to a loose connection in the detector, which led to the director of Gran Sasso resigning. Actually, he was so ashamed of what his institution had done.
I remember that now. Yeah.
But the joke is, I'm sorry, we don't allow faster-than-light neutrinos into our bar. A faster-than-light neutrino walked into a bar. That's the joke.
I get it. That's pretty good, though.
I think it's a good one, too. I wish it was mine, but...
That is pretty good, yeah. But what I find difficult to get my head around is that these things pass through the planet. I mean...
Yes, they do. Oh, yeah. They don't notice the planet at all.
Yeah.
But there is a detector. There's the ice cube detector down in Antarctica. This is a cube of ice, a 1 kilometre cube of ice, which has got, it's basically not festooned so much as impregnated with many, many optical detectors that would sense the flash of light. If a neutrino actually did collide and interact with a normal particle, then you'd get a flash of light. Which it will be detectable in ice cube. And I think they've had detections as well.
Oh, interesting. Fascinating even. All right, Keith, I think we covered it. Did we cover it?
We answered the question, but I think that was a value-added question, Keith.
Yes, it was. It's got lots of bonus material in there, probably boring as, all whatever, an old sock. But
oh dear,
we got there in the end. Thank you, Keith. Thank you, everybody who sent questions in. If you do have questions for us, please go to our website and send them in on the Ask Me Anything tab at the top. Just click the AMA letters and there's an interface there where you can send us text and audio questions. Please remember to tell us who you are and where you're from, and we'll do our very best to answer them all. And again, we're just... Yeah, we're on the cusp of not quite having enough questions. Got a lot of text questions, but audio questions are few and far between for some reason. But who knows? Get them into us. We'd love to hear from you. We love all these voices, all the different people from around the world. It's fantastic. And thank you, Fred, as always. It's been a great pleasure.
It has indeed. And good to talk to you this week, and hopefully we'll do it again next week.
Yes, indeed. And I'll get back to you on that free reel-to-reel tape recorder, Fred. Yeah. Nudge, nudge, wink, wink. Professor Fred Watson, astronomer at large, part of the team here on the Space Nuts podcast. And thanks to Hugh in the studio, who couldn't be with us today. He's a bit slow. He's an old Trino. And, you can't even get through a door. And from me, Andrew Dunkley, thanks for your company. We'll see you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.